So this section of the course is the one where I save my what's a good word for it? Broader comments. This is the section I save my broader comments for. I'm still young and I'm still working on piecing things together. Perhaps I'll never be done, but I like to. I think everything I've said thus far can be fairly well cited and checked, and it's in the quote unquote formal science. I like to make a few suppositions and suggestions based on my intuition and patterns I've noticed here, and I will do so. But I really like to talk about the people I call the seminal thinkers, the elders. People who have pushed the envelope, and just about every single person here is putting forth understanding that is, again, in the formal Western scientific structure, but seems to argue towards a broader understanding of the nature of things. I go back and forth on whether I need to justify bringing these topics up or not. I try occasionally to find relevance, and as it pertains to growing crops and growing plants, but I really do think the more open and coherent our own understandings are and our own beings are, the more well we are able to deal with life, to deal with plants, to deal with nature. And the more integrated our beings are, the better results we're going to get when we work with nature. I think nature reads our energy and responds accordingly. And so, not that I'm justifying myself, but you'll maybe soon see that I'm bringing forth some topics which are fairly out of the normal conversation. Before I go too far down the path, I'll start with a review of some basic sciences from the perspective of biology. We have assumptions among microbiologists. There's something around 1.5 million species of soil fungi, something around 3 million species of soil bacteria. Of course, we don't really know because all the microbiologists and all the decades and all this, languages that there's been microbiologists have come up with names for somewhere between 3 and 5% of them. I made reference to this yesterday, that something between 95 and 97% of the species of life that exist in the soil, the species, like cow, chicken, rabbit, cucumber, right? 95 to 97% of the species don't even have names yet in science, in Western science. We are deeply ignorant, profoundly ignorant about what's going on immediately below our feet. And yet we understand, it seems, that it is these people down here who are the ones that are feeding our plants. And that's the other point I want to emphasize, or the major one in this slide, is that this science seems to be pretty categorical that actually it is the life in the soil that is feeding the plant. And when the life in the soil is not flourishing, and the life on the leaf surface as well, and when that life is not flourishing, we should not expect our plant to be flourishing. This is a thoroughly different analysis than you learn in conventional agronomy. It's a foundationally different sort of mode of understanding. And I call it the biological perspective, the biological system, the biological understanding, life. I think, I started off by laying this out at the beginning of the morning yesterday, and I said, if you're not okay with this, you might as well walk out now. I'll give you a refund, because this is the foundational insight upon which the whole presentation is grounded. It's interesting when you have conversations with people about soil and about fertility and about gardening and about farming, that oftentimes their assumptions about what's right and what's wrong go back to precepts that are based on chemistry, not on biology. People talk about liming. They talk about putting NP and K down. They talk about pounds of N and all this kind of stuff. And that whole mentality is founded on the precept that the plant eats soluble nutrients that are in the water, because it doesn't have a gut to digest its food for it. that whole conversation is founded on this central precept, which I think is fraudulent. I think we can argue is fraudulent, as at least it's not how nature evolved it. It may work as a IV drip works, but it is not how nature evolved it. And so oftentimes people who take this course and get impassioned about such topics attempt to convey these ideas to other people and find that they're speaking not to each other but across each other. And I think this central precept about it's the life in the soil that is the plant is feeding, that is feeding the plant, is the foundational point to convey. And once that point is understood and agreed upon, then the rest of the argument can be conveyed and understood. So for whatever it's worth, I'd like to just review that and touch on that before concluding. We understand the importance of our gut flora. We understand the importance of colostrum and inoculation. These are the essential points about biology that I want to just reiterate. So chemistry, I haven't talked about enzyme systems. I haven't talked about human health and degenerative diseases and all that kind of stuff. So let me use this chemistry slide to touch on those topics. I sometimes address them earlier in the presentation, but it hasn't happened this time. In chemistry, we talk about a few, of course, a number of things, but we're talking about the nature of the elements and the structure of the elements. In chemistry, it is understood that every element has a certain size. Like one atom of copper is 1.5 angstroms across. An angstrom is a unit of measure. Doesn't really matter how big it is. It's not, copper may not be 1.5 angstroms, but the point is zinc is 2 angstroms and cobalt is 1.7 angstroms. Every element has a certain actual size. And also, every element, when it's bonding with other elements, like we talked about vitamin B12, when cobalt is bonding with amino acids, it bonds in a certain geometry. Think about a pyramid shape versus a cube shape versus like a soccer ball shape. We've got tetrahedrons, we've got octahedrons, we've got icosahedrons. Think about a Tinker Toys. Anybody ever played with Tinker Toys long ago? Maybe occasionally, recently, if you've got grandchildren or something. I have children, so I play with my children. The Tinker Toys, you've got this, you've got the one wooden piece that's got a shape with holes drilled into it, and you put the stick in, and then based on where the holes are drilled, the sticks are going to go out in a certain angle. That's like the bonding geometry of copper versus the bonding geometry of zinc. One has, they have different shapes, different bonding geometries, which determine the shape of the compounds that they make. And this is foundational when it comes to enzymes, which are a critical biochemical compound. And let me just talk about enzymes for a second. We've talked about hoop houses a little bit here in the past couple of days. I told you that I've got 8 hoop houses, which means that I built hoop houses a couple of times. And I like to use the metaphor of I actually taken some down and moved them over, and when I bought them, they were built, so I had to take them apart. And I've built, I've put up hoop houses a number of times. And an interesting thing about a hoop house, when you're building a hoop house, the pile of metal you start with is like as long as these 2 tables. It's 1.5 feet tall, 2 feet wide, not a big pile of metal. When you get done putting all the metal together, it's 95 feet long, it's 30 feet wide, it's 15 feet tall. It's a really big structure that came from a little pile of pipe. And the act of putting the whole structure together requires simply a 9/16 and a 1/2 inch. Right? A 9/16 socket and wrench for the bigger bolts and nuts, and a 1/2 inch socket and wrench for the smaller bolts and nuts, used over and over and over and over and over and over and over again to tighten all the bolts, to hold all the pipes together, to build the whole structure. Those few tools with those specific shapes used over and over again is all it takes to build this massive structure out of this little pile of ingredients. And as I understand it, that is those sockets, that 9/16 and the 1/2 inch socket or wrench, is very similar to an enzyme in its function in living systems, right? We use these sockets and wrenches and screwdrivers and Allen wrenches and star bits and square bits in mechanical systems to put things together and take things apart. These enzymes are those compounds which are used to do that exact job in living systems. When you are tying together amino acids to build a protein, you're literally screwing together the amino acids. The metaphor that's used for enzymes in school, if anybody remembers it from whenever it was, ninth grade or whenever, was a key that turns the lock. Something about that? People remember this? Vaguely, the key that turns the lock, and then the enzyme is the key that turns the lock. So basically, amino acids are these pipes, and the protein is the whole structure. And somebody's got to screw the pipes together to build the structure, and the enzyme is that compound that has the unique size that does the job of putting the pieces together, and then it's used again, and then it's used again, and then it's used again, and then it's used again. So what's exciting about this whole process of the minerals in chemistry as part of this larger conversation is each of these different elements has a different shape and size and shape, which puts it at the core of a different enzyme that's used for different jobs. And this is why it's so important to have that broad spectrum of elements present in the environment, is because these different jobs are critical for overall biological system function. If you are a car and your brake pads wear out, they are designed to be taken out and new ones put in. Is okay with that? If you're a car and your muffler busts out, your muffler is designed to have its old muffler taken out and a new one put in. If you're a human, your knee is not designed to be taken out and a new one put in. Right? Your liver is not designed to be taken out and a new one put in. If you're a human, you get 4 billion new cells every day. Every day, your body is identifying the oldest, junkiest cells and disassembling them, junking the parts that are unusable, and reassembling new ones. Every single day, 4 billion new cells are built in your body, whether you like it or not, against your will. It's part of your basic operating system manual. You are not designed to have pieces taken out and new pieces put in. You're designed to be constantly rebuilding yourself. If you do the math on how many cells you've got in your body, on average, ballpark it all out, you get a new body every 6 months or so. Your bones take 7 years to replace themselves. Your blood takes 2 weeks to replace itself. But you get a new body on average every 6 months. So inside of every cell is a nucleus. Everybody knows this. You've heard about this. Inside every nucleus is DNA. Everybody's heard about this as well. DNA is a really, really big compound. People may have heard about this. So when you're building this really, really big compound DNA, actually it requires a whole bunch of different enzymes to put the pieces together. You need a half-inch and a 9/16 and a Phillips head and a flathead and 3 different Allen wrenches and 2 square bits and 14 star bits to build one strand of DNA. And each of those enzymes has a different element at the core of it. When they were performing the Human Genome Project, they were not only identified all the pieces of human DNA, but they also identified all the enzymes necessary to put the DNA together. And then when they've done that, they could easily identify all the elements at the core of those enzymes. You guys okay with this? Dozens of elements are required to replicate every strand of human DNA. Dozens of different elements: copper, zinc, manganese, cobalt, molybdenum, boron, vanadium, selenium, chromium. Go for a while. How many elements are required to balance a soil test according to Virginia Tech? When Virginia Tech gives you recommendations for fertility,
NPK.
NPKs, calcium for pH, or sulfur for pH, generally are the only recommendations you get. I don't know about Virginia Tech. I know about UMass. I know about UVM. I know about Cornell.
They used to do more, the trace minerals, and they actually stopped. They ran out of budget.
They ran out of budget, or
Yeah.
who
Their
knows?
budgetary decisions.
At any rate, the question is, are we growing volume of crop, or are we growing food for humans? Where do we get these nutrients that our body needs to build itself from? They should be in our food. What does our fertility programs have to do with the nutrition of our crops? What is our job as farmers? Our job as farmers is to grow food, not to grow volume, not to grow bushels, not to grow bunches, but to grow nutrition, to grow flavor, to grow aroma, to grow health-giving attribute, as far as I'm concerned.
Well, ideally, they go, you're doing the flavor, the bushels.
But the priority is the
Follow.
nutrition, as
Yeah.
far as I'm
So where you're
concerned.
focusing.
Anyway, this is the whole conversation, this is the idea of the organization, is that we shift the conversation slightly to understand the importance of the nutrition itself from a foundational standpoint. And so what happens when you don't have one of those dozens of elements present in the cell when the DNA is being replicated? Well, you don't have the enzyme. What happens when you don't have the 9/16ths when you need to tighten that nut?
Can't tighten it.
Or you get the,
Then
you get the vice grips out. Yeah, exactly. Functionally, that piece does not get put together. There's a word for that. You know what it's called when your DNA, when one piece of your DNA does not get put together properly? A genetic marker, a mutation, a break in the DNA. So we can identify specifically the mutations, the breaks in the DNA, with the enzymes that weren't present, with the element that was needed to build the enzyme. We can say categorically chromium is responsible for the genetic markers that are correlated with diabetes. Categorically. End of conversation. We think diabetes is a disease that you need to manage for the rest of your life because it can't be cured, according to the doctors. Anybody heard of Hippocrates?
Yeah.
Hippocratic Oath? You know the Hippocratic Oath? First, then, let food be thy medicine. And finally, let me never be conned, tricked, or bought off into prescribing a poison. First, do no harm. No cutting, no slicing, no chemicals, no radiation. First, do no harm, then let food be thy medicine. Right? We've known this for a long time. We've known this, our humans have known for a very long time that, I mean, they don't know the science, that you get 4 billion new cells every day and that you get these genetic markers and DNA and enzyme systems, blah, 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 blah. We know that if you eat well, your body will heal itself because your body is designed to heal itself. It's not a machine that you have to take pieces out of to replace. It's a living system which is designed to be maintained throughout. So this is part of the argument for the mineral balancing, for the seawater, for the copper sulfate and the cobalt sulfate and the boron and everything else, is that not only do our cells have enzymes that are needed to build compounds in them, but plant cells do, and so do bacterial cells, and so do fungal cells. And all of life actually uses the same enzymes for the same purposes, for the same compounds. It's remarkably similar. And if we want to build life in the system, we need to be looking in a broad spectrum at all these different components. You do not need much of these elements. I said 2 pounds of molybdenum per acre is enough to facilitate the fixation of all the nitrogen your crops will ever need. 2 pounds of molybdenum per acre. That's not a lot. That's one of the bigger quantities, right? That's one of the ones you measure. A lot of these we don't even bother measuring because you need so little. I mean, you need them, but you don't need that much. I never learned this as an organic farmer. I never learned this as an organic farmer, and the permaculturists don't talk about it, right?
That's not true.
Do they now?
I do.
In general, the permaculture community,
teach.
right, and the organic community now talks about it as well, but historically, traditionally, these communities have not integrated this understanding. As far as I'm concerned, this is a piece of the puzzle that people in these
I think
communities
they
are very
talked about
receptive to.
A lot in the context of the dynamic accumulators and supporting micronutrients and nutrition.
Yeah. Conceptually, yes, perhaps. I shouldn't give the
Fermenting of
permaculturalists
foods,
a bad
trying
time.
to increase the,
Yeah,
get nutrition.
I'll take that back.
Filtration. Water's life.
Anyway, the larger argument is still in place, and that is that we need these elements for life to function. And so that's the point I wanted to make about chemistry.
I didn't learn it from them.
Didn't learn it from the permaculturalists. They're receptive. They're good people. They mean well. They're humble, and they say, "Oh, that makes sense." And I'm happy to use a little bit of seawater. Oh my God, look what happens when I do. they don't like to use things in bags that come from an industry in general. They push back against that, and so I say, well, use your local rock dust. And then they don't complain anymore. That's been my experience with permaculturalists. But biodynamic people, right, they're coming around to the idea that actually Steiner talked about the mineral realm as well as the etheric realm.
They're all frequencies of light.
Right.
Minerals are all crystal colors. If you go to a mineral shop, you'll see all the crystals and all the
It's
colors
been
and all the
great to
frequencies.
introduce this conversation to the biodynamic community as well as to the organic community because there's receptivity across the board. It's really exciting that when you frame these things well, we can actually begin to build alliances across the different streams in the movement. Anyway, I digress. Nothing out of the ordinary there. Physics. So vibration of the component pieces of matter sets up vibration of the whole is what I've got written here. I'm not sure what to do with that. Every mineral and compound has a frequency that affects every other aspect of the system. We talked, I think, a little bit about Alpha Centauri last time. Alpha Centauri being the star that's a long ways away, but we know exactly what's in it because of our reading of the vibration of the elements. Has anybody here ever been to an elementary school band concert? Oh, yes.
Well, actually, ours, we were so poor, we didn't have band in elementary.
But you've been to an elementary school band concert?
Yeah.
Everybody's been to an elementary school band concert?
It's a lesson in dissonance.
Vibrations?
Right, is my point. It's very sweet, it's very endearing, and it really grates, right? I mean, it's just like,
They should sell give earplugs out. And you go,
it's really bad. I mean, they're so sweet, they're so cute, the instruments are bigger than they are, right? We know what a dissonant vibe is. Ever been to an a cappella choir, a beautiful, exquisite a cappella choir that was singing so beautifully and perfectly in tune that there's this thing called an overtone or a harmonic,
yeah.
right? There's 4 people singing, and there's 5 notes that you hear because the lower notes are in such perfect attunement that the 5th note is sounded. We understand in chemistry that every element is a thing, that every compound is a thing. We understand in physics that every element is a vibration and every compound is a vibration. I would suggest that our bodies are made up of these things, which are vibrations, and that we each have a vibe. Everybody know what a vibe is? You gotten a vibe off of people? Right? You get vibes off of people? I find it really interesting how all these things overlay and correlate, and I would suggest that it was difficult for us to attune to our higher octaves, to our overtones, to our subtler natures when our vibe is dissonant. When our bodies are vibrating and out of tune because our compounds are not properly built, I would suggest that it becomes difficult for us to attune to our guidance and to follow our higher nature. This is one of the foundational reasons behind my passion about this question of food quality. When I was in my 20s, I went off the metaphysical deep end and was very passionate about consciousness and God and truth and enlightenment, and was, fairly dogmatic and arrogant and obnoxious about it. And at some point in my personal process, became aware of the fact that if people's bodies are vibrating out of tune, it will become it's very difficult for them to maintain the coherence, to maintain the attunement of higher consciousness. I understand that we are all eat food, that our bodies are built out of food, and I understand that if we don't have in our food those frequencies we need to vibrate coherently, then it will be very difficult for us to tune into our higher natures. So that's basically the point I want to make here about all these sciences, is I think there's an amazing correlation here between actually growing good food, which actually builds soil, which will actually sequester carbon, which will obviate the need for pharmaceuticals because we won't have these diseases, which will obviate the need for agribusiness chemicals. We don't need the fertilizers, we don't need the fungicides, we don't need the pesticides, right? We don't need these compounds. Not only do we address a lot of these systemic issues through the process of growing good food, but we actually bring people's bodies into coherence, which I think will help them tune into their higher natures, which will help them be more in line with that guidance that comes from the higher octaves. I've got quantum mechanics here written down, and they say quantum mechanics is the topic, is the opportunity for people who don't know what they're talking about to say whatever they want, because no one really understands what quantum mechanics means. So I take that opportunity here, because I've written quantum mechanics on the slide, to talk about these things and hide behind the term. We've got these things called dark matter and dark energy. I'm sure people have heard about dark matter and dark energy, and I think officially no one actually knows what they are, because the scientists, at least, we don't have the tools that can find them. Right? You know how this works? The tools that we have can see that there's something affecting what we can see, but they can't see what it is because they're not operating in the right frequency range. Again, like we know, we have named somewhere between 3 and 5% of the species of life in the soil. We can find somewhere between 3 and 5% of the matter in the universe. Right? Most of the universe we can't find. Our telescopes, our microscopes, all of our tools, all the tools of science can find something like 3, 4, 5% of reality. 95% of it, 96% of reality,